Regina, you are the best. I know. Okay, then, okay, the most important is in the definition for the function is that one value of the x is associated with the only one value of the y. Bueno, si es another, it's another. Maybe. Oh, pero si es another, y es the same, it's okay. Because definition is only one guy in the range. However, the violation is when you have two values of the x, or sorry, one value of the x associated with the two values of the y. It's a no okay. Okay, it's a violation of the function. Entonces, we're discussing in the last class different examples of the determine if function or no, using the set. No, the set is super easy. Now I want to discuss in another point of view, que es using the graph. Suppose que one graph is given. Suppose que one graph is given. Suppose four graphs. Four. Okay, this is x, y, x, y. You want to put different situation. And look in the graph. You determine if or if no function. Suppose the first graph look like that. The second look like that. This arrow indicate that this curve continue forever in that direction. Okay, just continue forever. Suppose another like that. Suppose another like that. Like a circle, no? Like a circle. So to determine if a function or no, we apply one thing important. Important thing is called vertical line test. Vertical line test. Okay, by the way, it's the same of the definition for the function, but in another way. So basically, you are doing hypothetical vertical line, like that. And this line crosses in only one point as a function. Look, like that, in different position, no, in different place here. Hypothetical, it's a bunch of vertical line. If cross in only one point is a function, si cross in 2 point or 3 point, look at that, this is no function. Here. So the answer is obvious in this example is yes. It's a function. Yes, it's a function. No, it is no function. And no, is no function. Using the vertical line test. Let me try to understand the idea behind vertical line test. It's elementary. Look, suppose one x value here, okay, called x1, is associated in the graph. When you go to the graph, two different y, y1 and y2. And you see that this is violation of the function. Okay. Actually, this is no one-to-one. The first one, no one-to-one, but is one many-to-one. Because, for example, another value here and another value here have the same y. But it's a function. This is one-to-one. Good. This is no function, and this is no function because one value of the x is associated with the two y. Super clear? Okay. Let's move on to another topic inside the same problem, the functions, is about the function notation. Guys, extremely important to master function notation because function notation is very convenient notation that we are using to make a transformation for the function. Okay, and a transformation we study, I suppose, Friday. Look, function notation. Function notation. Okay, function notation is relatively easy because we use one name of the function. Normally, the typical name is using one letter like that. F, G, H is the most popular. No, another is using P, M. But sometimes in mathematics using maybe no one letters, using 2 and 3. We study, I promise, in the test 4. One function that the name is LM. Another function that the name is LOG. And the trigonometric function that you study in trigonometry pre-calculus is sine, cosine, 3 letters. Okay? One letter, 2 letters, or 3 letters. No 4. 4, this is illegal. It's no common use in mathematics. Okay, so now you copy F, que is the name of the function, name. Okay, and you put the parenthesis and you put X here, F of X. And you read like that, F of X, F of X. So this is a special notation because these parentheses do not indicate multiplication. No. This parenthesis indicate that you evaluate one element in the domain. This is element in domain. Remember, it's domain. What is the domain definition? No, I want to repeat this idea several times throughout the course. Domain is the element of X. Okay, you have a set. The first set in the function is called a domain. No, so you say another way to say what is the domain? Well, the domain is the set of the element of X. X is the first set. You stay in the relation. Okay. Entonces, these parentheses do not indicate multiplication. No. This is que you plugging in inside the function. Okay. Let me illustrate using one. What is the powerful of this function notation? Because we can do transformation. We can do, for example, find the X in the set, the Y in the set. Let's see example, and you understand more clear now. Suppose elementary, f of X equal 4 minus X squared. This is given. This algebraic expression is given, you immediately associate with the function, you call the name, and this X is exactly the same. This X is the same X of this. But this is a square because it's a algebraic expression. Okay, so we are doing, for example, transformation. What is the typical transformation we're doing? When we're doing reflection. Reflection is you replace F for negative. I promise que not today, Friday, we study in detail transformation. But this is just introduction. And what is the convenience to using function notation to see more clear the transformation? Okay, so we are doing transformation. 104 stays the same. And you replace X for negative X, like that. And leave it like that? No. You apply some algebra, negative X squared positive X. In this case, by coincidence, stay the same. This and this is the same. It's a coincidence. And they have a special meaning, but I don't care the meaning. Okay, the most important is you understand it's possible using the function notation, see clear some transformation. In this case, was a reflection. Okay. Another possibility is, for example, you multiply by 2x here. This is another transformation. In this case, maybe when you multiply by a number, maybe it's outside or maybe it's inside. We are doing like a zoom in and zoom out. It's like a stretching and compressing. But don't worry for this now. The thing I want to transmit, explain now is what is the application of the function notation. Entonces, suppose I want to do this because I want to do one transformation. I don't know exactly si it's stretch, si it's compressed, si it's horizontal, si it's vertical. You replace X by 2X. By use substitution, instead of the original X, now it's 2X. I multiply by 2 or by 3 or by 4. And so I try to create transformation. I create a new function que es a family, ¿no? But this, okay, entonces es 4 minus, and you square, this 4, 2 squared 4, x squared. And leave it like that. This is the transformation. Entonces, in your moment, you can see what is the interpretation, geometric interpretation this. But no, it's not our problem now. Another possibility is to take the function and you affect my negative 1 outside. Oh, look at that. This is another reflection. Reflection, two reflection. Okay, reflection, one kind of reflection, another kind of reflection. Is when you replace x for negative or when you put the negative outside. And when you put the negative outside, I take the original equation, I affect by negative 1, that's a negative 4 plus x squared. In this case, not equal this. Well, okay. It's not equal, it's different. Okay. Sometimes it's equal, sometimes not. And when it's equal, have a special property we study in detail in your moment, not now. Remember, the idea today is just explain the application of the function notation. Another application is not only into the transformation. That was the collection of the transformation. Not all of them. Well, one more. Suppose I want to evaluate f and x plus 3. Ooh. You replace x, no by factor 2, no, x plus 3. In this case, transformation also, in this case, is like a translation. I don't know exactly si es a horizontal translation or vertical translation. I don't know, I don't care now. But basically, the transformation is 4 minus parenthesis x plus 3. You replace our x in the original expression for x plus 3. And the rest is piece okay. The rest is, well, you FOIL this guy. Entonces, x squared, open parenthesis, plus 6x plus 9. Okay, let me try here. X plus 3 times itself. X times x squared. Plus 3x. Plus 3x again. Plus 9. Because the last product is 3 times 3 gets 9, no? And when you combine 3 plus 3 is 6, like that. Boom. Okay, now, okay, the answer is 4 minus x squared minus 6x minus 9. When you combine that term, the only possibility is here. Is minus x squared minus 6x minus 5. Because positive 4 and negative 9 is negative 5. And this is the answer of the f and x plus 3. Basically, we are doing some transformation. We are doing reflection. Reflection, no. In this case, is translation. What kind? I don't know. We study in detail Friday. Okay, another application is forget about transformation. No transformation anymore. Suppose I want to find y in a set. We are doing several times in this throughout the course. Y in a set is the point when the curve and the function crosses the y-axis. So what is the formula to find what? Okay, it's super easy. Memorize. Apply function notation. You evaluate in 0. Okay, when you want to find in any function the y in a set is the point when the curve, when the function crosses the y-axis, you evaluate in 0 like that. So it's super easy memorize using function notation. Okay, let's do it. See my function again. We're using the same example. Easy, no complicated. It's this. You evaluate in 0. You replace x for 0 and the answer is 4. Therefore, I am sure that the point 0,4 is the y in a set. Okay, guys, this is the formula. Evaluate in 0. The formula for finding y in a set. Associate this idea with this formula. And what is the formula for finding x in a set? Well, it's similar. It's f of x equal to 0. In this case, it's the point when the function crosses the x-axis. Therefore, any point on the x-axis, y is 0. So basically, because the idea of the function notation is f of x equal y. Okay, f of x and y is the same. But this is more useful to make transformation. You can write like that, y equal, okay, 4 minus x squared. But you lost the information of the transformation. In this case, no. In this case, we have another. Function notation open a new door to understand. But in any time, if you want, you don't feel comfortable with the function notation or you don't need function notation, okay, no problem, I understand. You're using y because they are the same. Okay, go ahead. In order to find the x in a set, you put a function, you enforce it to be 0. Okay. In our example, the function is 4 minus x squared equal to 0. Wow! And we're solving this elementary quadratic equation. Let's do it. Let's do it. I move x squared to the right hand side. I apply square root both sides. Plus or minus 2. Square root 4 is 2. Plus or minus, don't forget double solution, is equal to x. Therefore, we have 2 points. The points are 2, 0 and minus 2, 0. Remember, this is x value, que is the first component, and the y, I suppose, que is 0. This is the y in both. Okay, this is super fantastic. Super fantastic. Let me try another example. Easy for you. Another example of the y in a set and x in a set. I promise that we are doing x in a set and y in a set anytime, every day in our lecture of the core lecture. Suppose another function I want to call different name, g. Is absolute value x plus a. And my goal is find y in a set and x in a set using function notation. Okay, I know that the formula to find y in a set is g evaluating 0. I should replace 0 for x. 0 plus a is a, the absolute value a is a. Therefore, the famous point is the point 0, a. This is the y in a set. In order to find the x in a set, the formula is g of x equal to 0. Okay, and g of x is absolute value x plus a. In this moment, we have equation that involve actual value. This is actual value equation. But remember, when it's 0, we have only one solution. So you remove the bar. In this case, you can remove because 0 is no positive 0, negative 0. This is equivalent to say x plus a equal to 0 and solve for x. X is equal minus. The famous point is minus a comma 0. This is the x in a set, and this is the y in a set. Any question? No? Okay. Let me move to another topic. No, it's the same idea for the function, but in this case, I want to cover one example. In the review packet, we continue another example in which looking the graph of the function, you can determine domain and range, and using your common sense and using your imagination. Okay, suppose one hypothetical example like that. Suppose the graph. The graph is given in the test. We have the curve, and the curve is a little bit complicated because contain hole. In this case, you need to interpretation this and this. This is a hole, this is no hole. So when the circle is open, it's undefined. When the circle is closed, it's defined. And this point is 2. This is 1. This is 3. This is 4. This is 5. This is the y value in this case 1. The y value of this is 2. Entonces in 5 we have the same situation. No, not the same. Like that, something like that, and decrease. Boom. And remember, this arrow indicates that this continues forever. I suppose that this move on to approach it to negative infinity, no? In the y value. And this is exactly the same, approach it to negative infinity, the y value. But this is supposition. Okay, and this is the same path. So what is the question? The question is determine, look in the graph, no mathematical, no nothing. What is domain and range? What is domain and range? The supposition always is domain is all real number. The supposition. The agreement is domain is all real number from negative infinity to positive infinity. Okay, and it's a negative infinity, it's a positive infinity, that direction. Okay, domain, remember, is x. Domain is you familiar up quickly to the x value. It's all real except restrictions. And we have restrictions when it's undefined. Entonces, when it's undefined, when you have, for example, that holes, it's undefined. The holes, the restriction is a holes. There are different restrictions. A gap, that is gap in which the function have no value. And another restriction, there are another. I promise that we study more. But specifically, I don't want to confuse it with another. We are concept. Basically is holes, gap, another thing. Okay. So is I can see, so in order to find the domain, I recommend pick arbitrary point on the curve because the x value you projection this point onto the x-axis. I can see that the domain is here. Look, projection, but here no, we have a hole because this is undefined. Projection. This is okay. And this part, no, we have no value, therefore, and this projection, any point, bam, but projection onto x-axis. When you're projecting, you see here we have all again, and it's continuous. So what is the domain? Well, the domain is from negative infinity. We have different pieces. From negative infinity to 2. And 2, remember, we have a hole, it's undefined. The function is undefined, no good. It's a restriction. And then, wait a second. I try to write parentheses, no bracket. Union, because we have different intervals. Another interval is between 2 and 4. Between 2 and 4. No include 2 and include 4 because 4 is closed, no open. So it's defined. So you evaluate this function. Okay, I don't know the name. Suppose que es h. Evaluate in 4. We can find value que es 2. So you want to evaluate the function in 2. We cannot find the value. It's undefined. That is the reason que in 2 is completely out the domain. Union, because I have another interval que is from 5. Of course, do not include 5. From 5, parenthesis 5, infinity. This is the answer for the domain. Okay, understandable. Now, what about range? Range is always a little bit more complicated. Always a little bit more complicated. Suppose, let me use in black color for the range. Range is the y value. So we are doing similar procedure. So you projecting any point on the curve, but projecting on the y-axis. Suppose this point. You project it here. So I can see, okay, from negative infinity, the range is, look, let me highlight it bold like that. This continues from negative infinity, but in 1 stop. Because in 1 we have a hole. And we continue to 2. I have no idea what happened exactly in 2, but I know very well that in 3, 4, 5 we have no value of the range. So I stop in 2. Well, and 2 is complicated because in 2 we have, look, we have here close and this we have open. and open and close together. When you're projecting, give me a close. Because this is defined and this is undefined, but win the define. Okay, so now basically the range is from negative infinity, is this guy here, it's continue forever, comma 1, not include 1, because in 1 we have a whole, union 1, comma 2, and yes, include 2. Okay, this is the idea for the determine the domain. Thus I want to put one couple of the example, no too complicated, easy, and you help me to understand domain and range, no? Please. Suppose 2 examples. Okay, question, guys, question. Sorry. Okay, I am doing fast. Do you follow me a little bit? Okay, see one friend asks you, what do you study in college algebra? Well, we study one thing weird, it's called domain and range. What is the domain? Well, domain is the set of the x value, and range is a set of the y value. Okay, it always is all real number. No. Sometimes no, because sometimes we have a point that's undefined. So this is called a restriction. So the agreement you suppose is if the domain is all real number and the range is all real number, but we have restriction. So you exclude the except them. Okay, so now let me try to do another example. And you help me to understand, not too complicated like this. Okay, we have whole, we have gap, no. We have normal functions, like that. Just 2 examples. The graph is given, and look in the graph, no mathematics, no algebra, only look in the graph, you determine domain and range. Suppose the first scenario is a line. Suppose que the function is a line, like that. Suppose que the second is a parabola, like that. And by the way, this point is important, extremely important, is -3. Okay. And the question is, look in the graph. It's a typical question in the test, please. Determine domain, range. Domain, range. Boom, 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 boom. This function maybe I call f of x, and this function I call g of x. Who help me? Domain of f. Range of f. This is of f. And this is of g. Well, I have no idea. I pick arbitrary point. And remember, this arrow indicates continue forever in this direction. When you're projecting onto the x-axis to find the domain, I can see, wow, it's already a number because the projection is coincident. We're using a little bit. The projection is coincident with the x-axis. Okay, so I suppose I pick arbitrary point, and I project, I get this point. And when you pick one point here, it's here. So it's all real number. And all real number you indicate from negative infinity to positive. Likewise, in the range, the projection is onto the y. Therefore, when you are doing the projection, you can see that the projection look like that. The projection this point is this, projection this point. So the range is again all real number. This is a very, very common case. Okay, we have no restriction because it's a line. The curve is the line. In this case, no, because in this case, the parabola, no? And the parabola, bueno, the parabola open in both directions. Therefore, the domain again is all real number. Why? Because you pick arbitrary point here and you projecting onto the x-axis. You see in both directions. Okay, suppose in this branch of the parabola and this branch of the parabola and the part in the middle also is that part. That's all real number, no problem. However, the range, no, because the range, I can see we have no parabola here. Like when you project the point here onto the y-axis, you can see we go from -3 to +infinity because this parabola open up. This parabola open up. Entonces, pero include 3, of course, because 3 belong to the parabola. This is an important point of the parabola. So the range is bracket -3, comma +infinity. So completely out the game. -4, -5. It's completely out. So it's easy. It's relatively easy. Do you follow me? Question. I want to hear opinion. It's easy. It's clear. It's confusing. I promise we go over the game. It's easy. We go over the game. Jose, okay. In the review.
I don't understand.
Say, English, opinion.
Hello?
Okay. No, you say something.
I don't really understand, but I'm just like following.
Super. Blanca, Covarrubias. Okay. So now I continue working with the domain, but in another point of view. Okay, this is the most interesting and a little bit more complicated. Determine the domain, pero no graphic. No. Determine the domain using the equation. So the equation is given. So determine the domain using the equation. Okay. Entonces now I need to explain what's the agreement for the domain. So I give you one function. Example 1. Let me call example 1. We are doing several examples. Is x plus 4 divided by x squared minus 2x minus 3. Entonces determine the domain. What is the agreement? The agreement is, I suppose domain is equal always all real number except the restriction. Except restriction. And how do you find the restriction? Well, we have two kinds of restriction, and they are combination. Suppose we have division, P divided by Q. So this example is classical division. You divide one function, one expression que I call P, x plus 4, divided by x squared minus 2x minus 3, que es Q. Entonces es obvio que we have restriction when the Q is 0. That's totally illegal division by 0. So you need, the restriction is Q never should be 0 or must be 0. So division by 0, because I want to avoid division by 0, que you know is undefined. You put in the calculator 5 divided by 0 is, and the calculator say in the display error. Okay. Another possibility is when you have a square root of the one expression I call E, capital E. This capital E expression must be non-negative. So greater than or equal to 0. Non-negative. Because I know what happens when it's negative, because a square root negative number is imaginary. And imaginary is totally out the all real number. This is all real number. Okay? And their combination. For example, one possibility, two possibility, another third possibility actually is the combination. This and this together is supposed to you have P divided by radical E. that you have the radical in the numerator, the restriction look like that. You have the radical in the denominator to say the combination this and this to say capital E is just positive because 0 is illegal because the square root 0 is 0 and division by 0 is wrong. Okay? Entonces, we practice that. We practice that. I bring several examples. 1, 2, 3, 4, 5. Complicated, super complicated. This is important. This is one question in the test. I give you the equation and you discover what is the domain. No range. Range is extremely complicated. It's beyond. Range is only graphical, but the equation is very complicated. So the domain, basically domain, using the equation. Okay. I can see that this function look like similar to the restriction number 1, que es division to thing. So you take the polynomial in the bottom, que es q, minus, no plus, es minus 3, and you enforce it, it's impossible to be 0 because undefined. Okay? Basically, this idea is this idea. Do you see? Okay, but I don't feel comfortable with this inequality, so I transform it to equation because I am super familiar with the quadratic equation. Actually, this is a quadratic equation. I solve this quadratic equation. So I need to find the solution for this quadratic equation as the bad guy, as the restrictions. Okay, in this case, easy by factorization. It's 3 and 1, no? 3 and 1. 3 times 1 is 3. Somehow 3 minus 1 is 2. Minus here, plus here. So the solution is 3 and negative 1. Entonces, actually, this is the bad guy. This is a restriction. But how you write that? You write okay, the domain is all real number except the bad guy, so except all real number. Let me write in different way. However, in the test, I ask you specifically in interval notation. So any answer of the interval of the set, you express in interval notation. But let me try to explain first of all in English. After we are doing the sketch to understand, and finally we are doing the famous interval notation. No? Basically, it's all real number. The domain. Wait. Domain. Here's the goal. Domain is all real number. You put in English if you want, or you put it in mathematical language like that. Wait, except 3 negative 1. Okay, this is illegal value, no? Okay. If you want, you put no equal, and you remove the word except. It's the same. You put the except and put the bad guy. Entonces now to understand this, look, I draw my all real number line. Okay, this is the all real number line. And we have two bad guys, que es 3 and negative 1. 1, 2, 3, and negative 1 que here. So I know that in this value, we have a hole, like that. Hole and hole. And the rest is okay. I highlight this, I highlight this, yeah, I highlight this. So what is my beautiful answer in interval notation? One, domain is from negative infinity.
From negative infinity to 1.
Say something?
Yeah, I said from negative infinity to -1. From to
No.
oh, from negative 1 to 3.
Eso. Negative 1 to 3 is okay.
Yeah, and also 3 to plus infinity.
Super. Because we have 3 pieces. Look, one piece, this piece is this. This piece is this. And this piece is this. Everyone follow me? Do you understand very well? Okay, guys. Unfortunately, actually, this answer is correct. However, in the test, I like this way. because I specification, I need the answer in interval notation. This is interval notation. Okay? This is the typical notation for every test, interval. Okay, let's continue example 2. No question? Everyone understand very well? This is a little bit confusing. I understand very well. But little by little, you get the idea. Let's move on to example 2. On example 2, there's no big deal. Is find the domain, okay, again, the same question of that function, no? Is g of x is equal to square root 3 minus 2x. And of course, press the answer in interval notation. Okay, one more time, I check in just in case the restriction formulas. The restriction formula, remember, we have restriction 1 when it's division, we have restriction 2 when this is square root. Maybe we're using this restriction 2 because it's a square root, right? And the restriction 3 is also a square root, but on the denominator. We have no denominator in this expression. We have only one expression in the numerator, so we have no denominator. Denominator 1, no? So basically is the restriction 2. The restriction 2, let me make a zoom to see both things simultaneously. And you take the expression inside, que es e, the expression inside the square root, and you enforce it to be non-negative. Entonces you convert the problem in one inequality, and the rest is solving the inequality. And that's it. Let's do it quickly. Minus 2x, I move 3 to the other side, like a minus 3. Divided by negative 2, both sides.
Yeah.
Better be careful. What happens when you divide one inequality by negative number?
The sign gonna change.
Exactly. Switching the sign. The less down equal, right? And negative by negative positive. So actually is x less than or equal 3 half. You know, 1.5 in decimal, no? Okay, now the thing of the interval notation. Let's do in the part of the interval notation. I copy in the paper my famous all real number line. Infinity, negative infinity. Okay, 0 in the middle. 1, 2, 3. And negative, I don't care. 1.5, I suppose get here in the middle, in between 1 and 2 and 1.5. And this is less than or equal. Less than or equal is to the left. To the left. It says to the left is something like that. Include 1.5, que es 3 half inside. Yes, include because it's equal. And the symbolic way to indicate this idea is a bracket. So what is the domain, guys? Domain in interval notation is
minus infinity,
comma,
yeah, 1.5.
1.5. Parenthesis or bracket?
Bracket.
Absolutely, because include. How do you know que include? Equal sign.
Yeah.
Equal sign, give me information, que include the sign. Was clear this example 2?
Yeah.
Let's move on to example 3. But let me erase the board. Because see, I do not erase the board become a little bit slow when you have too much information. Suppose example 3. In the example 3, we have, okay, the name of the function is h, is 4 over square root x minus 9. Find the domain of this function. Okay, so I quickly recall. Remember 1, 2, 3 restriction. 1, 2, 3. The restriction 1 is p divided by q. When it's division, no zero denominator. When it's a square root of e, is e non-negative. So non-negative means positive or zero. And when it's in the division, radical is e just positive. The rest is illegal. It's obvious that this function matching perfectly with the case 3. because it's a square root in the denominator. So you take the expression in the denominator. It's amazing because you remove the square root. You don't care that 4. This 4 is not important in the problem. And you enforce it greater than 0. And that's it. Let's solve this inequality. This inequality is super easy. It's greater than 9. I represent graphically this idea. Negative infinity to positive infinity. 0 in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's greater than 9. Greater than 9 is in that direction. And of course, do not include 9. It's obvious that do not include 9. Because if you plug in 9 here, let's see what happens. 9 minus 9 is 0. And division by 0 is on the 5. The domain then is domain of h function is equal, parenthesis, 9, infinity. There's a number greater than 9, do not include 9. 9 is illegal because 9 on the 5, because 9 minus 9 is 0, 0 in the denominator is on the 5, you know. So you need to avoid the 3 situations. Division by 0, illegal. Expression negative inside the radical, illegal. Well, at least in the real field, because it's complex or imaginary. And several combinations. They are combination. Okay, let me see example 4. Very, very interesting example 4 now. Look, example 4 is, suppose the function que call P of x, is equal x over x squared plus 1. Entonces, again, repetition. The 3 classical restrictions. P over Q, Q non-zero. Radical E non-negative. P divided by radical E just positive. In this example, we have no radical. So this and this doesn't work. The only possibility work is the first one, que denominator non-zero. The denominator is x squared plus 1, non-zero. Okay. Immediately I replace this sign is not equal to by the equal to, because I feel more comfortable, because this is a quadratic equation. I solve a quadratic equation every day. So I move, this is incomplete quadratic equation, not necessarily quadratic formula. We apply the square root, both sides. And x is equal plus or minus, square root negative 1 is high. So let me repeat something. This is extremely important. When you try to find something in algebra, and you discover that the answer of this something you try to find is imaginary or complex, is because the reason, the interpretation is because do not exist. Or at least do not exist in the real field, no?
That's mean you can't find anything for it.
Anything. I planning to find something. I set up the equation. I apply my best algebra. I discover that the solution is imaginary or real or complex. The interpretation is the thing you try to find do not exist. Okay? Do not exist because the complex and the imaginary is totally out of the real field. Okay, so in this case, the restriction that I try to find using that formula do not exist. And remember, the supposition, the assumption always is the domain of the function is all real numbers except the restriction. And the restriction I try to find do not exist. Therefore, what is the domain of P? What is the final answer? Exactly. Domain of P, she said. Domain of P is all real number. Again, interval notation, you can find it. Okay. Super. Okay. Let's see complicated example. Now I want to complicate your life now. a little bit. I want to complicate. Erase the board. I can or no?
Yes, you can.
Suppose example 5, no? It's example 5 now. Example 5. We have a function I want to call f of x, but this function contains two radicals, x plus 4 and x minus 5. And the equation is the same. Determine the domain of this function. There's a repetition, the restriction. Restriction, three kinds. Is p divided by q when there's division, the denominator not zero. When there's a radical in the numerator, non-negative. When there's a radical in the denominator, just positive. So it's obvious in this case we have two radicals, and this radical is in the numerator. So we apply the restriction number 2. But you apply twice, 2 times. So you set out two inequality. And this inequality you connecting by and, because you need to satisfy one condition and the second condition. And the set of the interval to satisfy both conditions simultaneously is the domain. Okay, so you set out like that. You copy the expression inside the first radical, and you enforce it to be non-negative. And x minus 5, again, non-negative. But in this moment, we have a compound inequality. And the compound inequality, remember, in intermediate algebra, we solve it separately. Finally, we connect it graphically. So x greater than or equal minus 4, done. X greater than 5, equal 5. And now, always in the compound inequality, we end in graphically. It's a 0 in the middle. 1, 2, 3, 4, 5. 1, 2, 3, and negative 4. Okay, the first part. Go ahead.
It's minus infinity to minus 4. The first part.
Yeah, right, you're right. So the first part, okay, put in blue color, is, from negative 4 to infinity, because the symbol is greater than, so it's in that direction. Okay, I put like that, no directly highlight on the line, because this is auxiliary construction can help me to understand the problem, no? And this case bracket, because including negative 4. And the second inequality is from 5, include 5, of course, again, to infinity, like something like that. I need to connecting the blue and the green interval. What is the connection with the and? And remembers intersection. And means the common element. What is the common element between the green and the blue?
Minus 4 to infinity. No, minus 4. Yeah, minus 4 to infinity.
No.
No, 0 to infinity.
No. Okay, repetition the question. Try to meditate, it's easy, the answer. Okay, the interval is blue is from negative 4 to infinity. The interval is green. Go ahead.
Sorry, mister. I thought that was a 0. Is that an 8?
That's 5
So
to
that's a 5, right?
That's a 5. That's a
Super,
5.
Yeah, so it's 5 to infinity.
Super. This is the answer. The answer is the green. Because totally green is inside the blue. Therefore, the intersection, que es the common element, is obvious, que is from this to this. Okay, include 5 or no?
Yes.
Yes.
Domain is equal bracket 5 comma infinity. End the story. And remember, when the endpoint is infinity, infinity is no number. Infinity is a symbolic way to indicate also that this interval continues forever in that direction. So you never reach infinity because it's too far. So therefore, never you put a bracket. This is incorrect. Put the bracket. Only parentheses because it's too far. I never touch. Do you understand this example? Gets a little bit complicated because it's basically this example I offer now, number 5 example, is the combination 2 restriction. But 2 restrictions of the same kind. But it's too radical. Let's move on to the example 6. Example 6, you see more complicated case. Let me show you. Example 6. In the example 6, we have G is a negative. And we have square root 2x plus 1 divided by x minus. Okay, wow, what the hell? Look, I review quickly my restriction. We have 1, 2, 3. And they are combination, of course. In the restriction 1, we have division. And illegal, denominator 0. Well, we have denominator here. Maybe we're using that. In the restriction 2, we have a radical in the numerator in the top part, and the expression inside the radical must be non-negative. And the third restriction, so you apply also, because we have this radical. This radical you apply. And this no, because this is the radical in the denominator, we have no radical in the denominator. This no. So you basically, in this problem, you apply this restriction number 1 and restriction number 2. And restriction number 1 is easy. You take x minus 2, minus 4, sorry, no 0, illegal. And restriction number 2 is 2x plus 1 greater than or equal to 0. That's it. If you form it, you set up the compound inequality. Okay, with the radical in the top, illegal to be negative, the expression inside, and the expression in the bottom, illegal to be 0. So I immediately, I don't like this symbol. You convert to equation. No, actually it's okay. No, leave it like that. I move 4 to the other side, no 4. Basically, what happened in 4? What happened? In 4, we have a whole. Here, no. Here is 2x is greater than or equal minus 1 divided by 2. X is greater than or equal negative 1. Okay, now put together. Okay, remember, in the compound inequality, it's always ending graphically. The last part is do the graph. Do the graph. Oof, my line is no good. Well, I have a rule, no? No, but the rule is complicated. The rule is complicated. 0 degree, totally horizontal. Okay. Boom. Something like that. Okay, good. No rule anymore. This is positive infinity, it's a negative infinity. 0 in the middle. So we have 4. In 4 we have a whole. 1, 2, 3, 4. In 4 we have a whole. Let me represent the whole like that. Boom. See, I represent only this statement. Is all real number in both directions. I highlight. And in 4 we have a whole. Now this part is negative 1/2. You suppose that this is negative 1, then negative 2, this is positive 1, positive 2, positive 3, positive 4. Negative 1/2 is located here. Negative 1/2. Negative 1/2. In what direction is I suppose it's to the right, no? Because it's greater than or equal. This is negative 1/2. So include negative 1/2. The negative 1/2 here. Negative 1/2 is a bracket. Greater than, so it's something like that. But unfortunately, we have a hole in the middle and it's continued. Okay, do you understand very well this or no? What's confusing? Okay, another point of view is, look, let me try. Okay, the first part is Nov4 is here. So you highlight, for example, in green color, is all real number, but in 4 we have to hold. In another line, in another line, we have zero gain here, infinity, positive, infinity, negative. And exactly negative 1/2 is here. Negative 1/2 here. We have this interval. They need to find the intersection between green and blue. Well, of course, one guy here is not common. Because belong to the green, but don't belong to the blue, no? And this part, yes. Perfect. And this part, yes, perfect. But in 4, no. So, from negative 1/2 to positive infinity, exclude 4. It's exactly the idea that I tried to do original, but it was maybe not clear. So I need help. What is the domain? What is the domain of the function? I forgot the name of the function. The name is G. What is the domain of G?
I think it is.
Go ahead. Is how you write
4
in interval notation, please. In interval notation.
Okay.
Go. Come
on. Minus 2 minus 1/2.
Pero bracket o paréntesis.
Bracket, yeah.
Bracket.
Half, negative 1/2, comma.
Yeah, 2, 4.
2, 4, and parenthesis or bracket.
Parentheses.
Union, because we have 2 pieces.
And
From?
4. Yeah, 4 to plus infinity.
Absolutely. This is the answer. Okay. Any question? Do you understand very well this guy? Oh no? Well, it's very confusing.
Yes.
Okay, super. I bring 1, 2 more examples. 2 more examples. Okay, 2 more examples. Suppose example 7, no? Example 7. In the example 7, we have P of x is equal square root 2x plus 3 division square root x minus 4 minus 8. Okay, let me try to remember the restriction. I don't remember. The restriction are 1, 2, 3. When there's a division to expression, it's illegal que denominator is 0. When you have a square root in the top, expression inside, non-negative. And expression in the top, non-negative. And when you have expression in the bottom, is just positive. But we have this possibility, and this possibility. Why? Because we have denominator. Okay, let me try one by one. So I discover denominator. Yes, we have. So say you copy. Is square root x minus 4 minus 8 illegal to be 0. No 0. That part no 0.
We're gonna
And you connect it by and. Number 2 is the radical and the top.
to x plus 3.
Plus 3. Should be non-negative. And
8 minus 8.
Uh-huh. The radical and the denominator, no, non-zero. Right. So basically, look, you apply restriction 1 here, you apply restriction 2 here, and restriction. Because it's illegal here. Okay, this radical is okay. Let's solve it. How you solving this complicated? No, it's complicated because you solve it separately. Okay, and also you intersecting finally in the number line. Okay, let's focus in this first part.
Yeah.
And this part, I need to identification using my knowledge of the algebra and the test one. Okay, this is inequality, but I don't like this inequality. Much better for me, at least put like equation, no? But
Yeah.
you know, this is the negation of this. So when you find the solution for this equation, actually, I know that it's not the good guy, it's the bad guy because it's not equal to 0. And this look like similar to the, what's the name of this guy? It's a radical equation, no?
Yeah.
What's radical equation? Okay, it's a radical equation. So this radical equation, for example, you solve for, you isolate the radical, you move a to the other side, you square both sides. This is the classical solution for the radical equation. X minus 4 equals 64. And x is equal 64 plus 4, no? It's 68. Actually, 68. This is the bad guy. So actually, I change intentionally because I don't want to confuse that symbol. But actually, this symbol is this symbol, this symbol, this symbol. That guy is 68. In 68, we have a hole. In 68, we have a hole. And this problem. Okay, I don't care. Let's continue. Moving on to the second inequality. It's 2x plus 3. Because actually, I put greater than or equal. I move negative 3 to the other side, divided by 2. Is x greater than or equal minus 3 over 2. Okay, it's equivalent minus 1.5. I put in decimal because in decimal is at least for me easy to see in the number line. And the last part is x greater than 4. Okay, put together everything in the number line. This is my famous real number line. The first restriction, this is 0, I suppose. The first restriction is in 68. 68 is too far. I suppose que here. Suppose que the scale is not exactly, but it's okay. The 68 is a hole. Entonces, this restriction represents a hole in 68. And the rest of the number is okay. Okay? The second, let's move on to the second, is 1.5. Suppose que this is 1, this is 2. Okay, let me use in blue color. And this is 1.5. And this is included, bracket, 1.5, but it's to the right, no? Like that. To the right. And let's move on to this 4. I suppose there's 2, 3, 4, 4. And 4 no include parentheses.
Professor, can I ask you a question, please?
Well, let me finish. Now, in 4 is 4 to like that. Come on, go ahead. Question. Ask me a question.
It was minus 1.5. I see you put it in front of the 0. I thought you see behind the 0. I thought you put it in front of the 0 because it's minus 1.5.
Sorry, you're right. You're right. I am crazy. Let me erase everything. This is negative, not positive. So this is completely wrong. Let me erase that part. This is 1, 2, 3, 4. This is -1, and this is -2. Thank you. -1.5 is located here. -1.5. Using blue color is this to this. And I suppose que es bracket here. But wait a second. I'm using blue. No. Blue pen. Like that. It's a bracket here. Bracket 3.5 or pero 4 is a bracket. No, it's no bracket. Okay. Entonces, basically, let me summarize the whole here. We have two intervals, blue and this color que es rainbow. Entonces, I need to intersect it. I need to find the common part. The common part is, I have no idea. The common part, where's the common part? Where's the common part? 4. Okay, pero 4, okay, wait, I agree with you. Es 4, pero 4 paréntesis o bracket?
It's gonna be bracket.
No, it's parentheses.
Es paréntesis.
Because
Why?
it doesn't have a
Let me try to understand. In this interval, do not include 4. In this interval, yes, include 4. Because this guy is the blue, include 4. And the other, no include 4. Entonces, the intersection, este común, que both, incluye both, es no 4. Entonces, from 4, comma what?
2 plus infinity.
No, remember the whole.
Oh,
we have 68.
Oh, to 68. To 68. To 68.
68. Bracket o paréntesis?
Here, I think it should be bracket.
Oh, it's a whole.
No,
Look, let me highlight. My answer is parenthesis here, this interval. Stop here. No 68. 68 the bad guy. Look at that hole. And this continue forever to positive. Entonces,
now I understand.
parenthesis, union, 68. Oh my God. Do you see or no?
Yeah, I understand.
Okay. Super. Okay, guys. Let me spend the rest of the time to present to you. Let me try to find Desmos. Something. Okay, I forgot to find. Wait for me for some second. Okay, there you go. Okay, there you go. I found. Super. Okay. I want to present to you. I come back to the whiteboard. This, you see whiteboard or no? Okay, stop sharing. Basically, whiteboard. Okay, erase. Okay, I want to present to you the most common function que you need to memorize in college algebra. So basically, Friday we start one topic is transformation. Pero transformation of what? Of the basic function. So basic function functions in college algebra. They are infinity functions, but they are some que es basic. Basic is like a mother function, and after that we are doing transformation. Okay, let me switch into to Desmos. Okay, in Desmos here. In Desmos, let's change the screen to Desmos. Look. Look at that. Do you see Desmos? So I want to discuss one by one the functions. I want to send to you when the class is over. I want to send the link connected with this Desmos. This is this Desmos living in my account, but I share with you and your account. That you can modification, you change something because you don't change my account. Okay. Okay, this is the how many functions we study now? 1, 2, 3, 4, 5, 6, 7, 8, 9 functions. Okay, the first one is super easy. The first one, you need to identification name. And after I want to send to you one paper in Word que summarize the idea for the function. So when the class is over, I want to send two things. I want to send, number one, this link of Desmos for the basic function, and one document in Word que summarize the idea for the function. Why is important this part? Because we are working using that function. So next time we study transformation, but transformation of what? Of this function. Okay, introduced to you now. Okay, let me see the first one. The first one is a constant function. The constant function is easy because it's y equal any number. Okay, entonces it's a horizontal line. Look, it's a horizontal line. Domain of this function is all real number. And range is just one number, que is in this case 2, because the y value is always 2, regardless the x value. So this is weird. Domain is all real number because this line is extending horizontally in both directions. It's from negative infinity to positive infinity. However, the range is only one number. Okay. In the document, you see another property that maybe you don't understand so far, but in your moment you understand. Okay, this is my first elementary constant function. Constant. What is a constant? Because stay the same value, 2, 2, 2, 2. No increasing, no decreasing, no constant. Okay. Okay, the second that we study is easy. Is identity. Look, identity is a line. Is y equal x. Look, let me show you. Y equal x. Constant, I delete constant. It's a line, but this is elementary line, no transformation, because the slope is 1 and the y-intercept is 0,0. Is identity. Y is the name of the identity because x is equal y. There's a function a little bit stupid, no? Because when the x is 1, y is 1. When the x is 2, y is 2. When the x is negative 1, y is negative 1. It's the same. That is the reason it's identity. But not stupid, it's important. In your moment we study in detail, or we using in detail identity function. In this case, I can see that this line is extending in both directions. So the domain is a real number, and the range is a real number also. Okay, do you see it's a real number? Both domain and range, guys. Do you see the domain and range of the identity function is all real number? Because this line extending in both directions, all real number. When you're projecting, it's all real number. Yes, good. Let's move on to the next one. Identity was easy. Quadratic function. Bueno, quadratic function es de parábola. Famous parábola. Look at that. Parabola. In this case, the parabola open up. Okay, the formula of the quadratic function is y equal x squared, degree 2 square. This is a parabola open up. I promise that we study in detail quadratic function. And the test 3, we study in detail again quadratic function. And what about domain and range? Well, domain is a number because this parabola extending in both directions from positive infinity and negative infinity. If you project any point on the parabola onto the x-axis, we have from negative value, positive value, from negative infinity to positive. However, the range no, because we have no parabola in the negative part. We have parabola only in the positive part. The range is from 0, include 0 bracket, to infinity. To infinity. Don't worry for copy that, because I will send a document that summarize everything, domain, range, and another property that maybe you don't understand very well. But in your moment, you understand very well. Okay, this is the quadratic function. Oh, nice to meet you. We're using next class because we are doing transformation. Transformation means I want to do something. I want to move this parabola. I want to compress this parabola. Maybe stretch this parabola. Maybe reflection this parabola. This is the transformation that we study, but no now. In the next, Friday we study transformation. Okay, entonces quadratic function nice, no problema. Cubic function, cubic function is third power. And the graph of the cubic function look like that. Boom, look at that. It's completely different, no? Because when the exponent is odd, is the aim behavior for the graph is is to the right up and left down. And look in the quadratic, the aim behavior is different. It's right up and left up. Always is up in the quadratic. And this is valid. See, the exponent is 4, the exponent even is similar. Not equal, but similar to the quadratic. When the exponent is odd number, like a 3, like a 5, like a 7, it's similar to this. Similar. Similar is not exactly the same. Entonces, the domain and range in this case is all real numbers, so from negative infinity to positive, both. In the parabola, no, look at that. In the parabola, we have limitation for the range. It's only positive, including 0. In the quadratic function. And the cubic function, no. We have positive and negative, both x and y. Therefore, the domain and range is the same. All real number. Now, a square root. Wow, look at that, square root function. A square root function is classical. A square root is, we have only one branch because I know that the domain is only positive and 0, including non-negative. So it's 0 because the square root 0 is 0. And the positive number have a square root, but the negative number, no. It's imaginary, and imaginary you don't see in this plane. You see in another complex plane. Okay, I don't care. Now, you don't see that. Therefore, domain is bracket 0, infinity, and the range is the same, bracket 0, infinity. Only positive, both, x and y. Okay, this is a square root function. We're using in the future. Cubic root, cubic root. Wow, what is different? Cubic root is similar shape, but have positive part and negative part. Oh, the reason is clear. Because the square root negative number is imaginary. However, cubic root of negative number, no, it's not imaginary, it's real. Okay, let me try to explain this. Quickly, of course. I go to the board. Here. Switching board. Okay, I am the board. Okay, look at that. I know very well because I passed the test number 1. The square root negative 25 is no real solution. That is the reason in the graph of the square root function, we have no negative part, only positive. However, cubic root, yes. For example, cubic root negative 27 is negative 3. And negative 3 is real. Why? Let me explain. Because negative 3 times negative 3 times negative 3, 3 times is negative 27. That 3 minus negative times negative is positive, positive times negative is negative, and 3 times 3 is 9, times 3 is 27. Exactly the same value you have inside the radical. Therefore, the cubic root contains positive part and negative part. This is the function cubic root. This is the function square root. Okay. Do you see the difference? Yes, super. Little by little, guy. This is a complicated test. Too many details. Okay. Let's move on to the decimal, no? Yeah, there you go. We have them or no? Oh, yeah. All right, let me see. Switching to decimals. Yes. You see. Good. Okay, so we studied cubic root. Now reciprocal. What is the formula for the reciprocal? Look, it's 1 over x, reciprocal function. Well, reciprocal function is, the graph is the blue color. We have this dotted line that you don't understand very well what is that, but don't worry for this. The problem is that the domain and range of this function is all real number except 0. The only bad guy that we have in that problem is 0. In 0, 1 divided by 0 is illegal. It's undefined. Therefore, the reciprocal function have this shape, a little bit confusing. We have two branch. The positive branch and the negative branch is symmetric. When you apply the symmetry, you see it's symmetric, but so far you don't understand how you apply symmetric, because symmetry is the transformation, no? But the most important is the formula, 1 over x, and also the domain and range. Domain is all real number except 0. 0 is the only bad guy. Okay, we have in the reciprocal function, and the range is exactly the same. All real number except the 0. Okay, one more is actual value. You are familiar with the actual value. Actual value is something like that. Actual value. Okay, actual value is look like a B, no? Okay, it's when it's positive, the answer is positive. When it's negative, the answer is positive. So actual value is a function that always the value that give me after the processing the function is positive, regardless if the value for the domain is positive or negative. Now, in this case, the domain is all real number because the actual value is a function that open forever in both directions. Open forever in both directions. So the domain, again, is all real number. But the range, no. Because the range is the y value, and when you project any point on the curve onto the y-axis, you see that only is valid the positive value. The negative value is totally illegal, the actual value answer. Therefore, the range is bracket 0, infinity positive, and never negative. This is the actual value graph. Guys, in the homework is waiting for you online. We have complicated example of the transformation, and you need to, because the function that they are using and I am using in my test is this function, no another function, this function. Okay. The last one is a little bit weird and complicated. I want to explain it. It's graded integral function. Let me show you. Okay, the symbolic way. There are many symbols. Okay, look like stairs. Look at that. Wow. I need to understand floor. The name is a floor. Okay, let me go to the board to explain the idea for the graded integer function. Graded integer function. This one. Graded integer function. Okay. The symbol, there are many symbols. One symbol is something like that. F of x. X equal floor of x. You say, well, professor, you say at the beginning we have 3 letters, but we have 1, 2, 3, 4, 5. I don't know. Another symbol is something like that, like a double bracket. And another symbol is something like that. Okay. And another symbol that you see in the book is using int, integer. It's like an integer. Let me explain the idea behind that function, because it's a little bit weird. Okay, suppose I want to compute a different value of this function. Okay, basically the domain is on real number. This is my all real number line from negative infinity, positive infinity, negative infinity, 0 in the middle. And suppose 1, suppose 2, suppose 3, suppose 4, negative 1, negative 2, negative 3, negative 4. Enough. Suppose I try to compute using, let's use that symbol. Suppose using the integer or graded integer of 1.5. Okay, 1.5 here. And this is what is the idea behind that function. It's a graded integer. The integer number less than 1.5 is 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, blah, 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 and continue. So the number, because it's the greatest integer is a number that is no fraction and no decimal. It's negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. It's an integer number, no decimal, no fraction. What is the bigger? What is the greatest? The greatest is obvious que es 1. Because 1.5 is located. 1.5 is no integer. 1.5 is real number. 1.5 is here. It's real number. Likewise, the function applied 1.6, 1.7, 1.9 is just 1. By the same reason. In 2.5 or 2.4, whatever, 2.4, es obvio que es 2. Entonces es easy to understand. Suppose here 1.0.3. Greater integer of 0.3. Es obvio que es 0 because notice don't participate 1. The collection of the integer number less than 0.3 is 0 or negative 1. So you take the bigger que es 0. What about greater integer of negative 1.5? What do you think about it? Greater integer of 1.5. Well, I locate 1.5 here. 1.5 is in between negative 1 and negative 2 here, I suppose, no? It's a negative 1.5. And the collection of the integers number less than 1.5 is starting negative 2. So no 0, no negative 1. Entonces the answer is negative 2. Okay. Do you understand the idea behind the graded? Hey, with noise. putting off the microphone. Jose Salazar. Jose Salazar. Off microphone. Eso. Bueno. Do you understand the idea behind that? So let me show you one more time the graphic of this function. Do you see the decimals? Okay, suppose, look, let's make it zoom. Suppose this is 1, this is 2. And between 1 and 2 is 1. And between 2 and 3 is 2. And between 3 and 4 is 3. And between -1 and 0 is -1. And between the number in between -2 and -1 is -2. Do you understand the function? The function look like stairs. Okay, integer. Okay, guys. Entonces, I want to send now the link connected with them. Okay, because we are working with this next class. Next class, I start new thing, but we are working with the basic function, the collection of this basic function. No, I want to send the link connected with this, and also I send the document contain more characteristic graphic. Okay, you want to print or not necessarily print. You have in your computer and you see what you need. Okay, guys, too much for today. Remember, today I finish grade the test, and the extension for the student can have delay is to the November 9. I waited to November 9. I checking, see you don't do anything, 0. Okay, or stay with the same grade. For the test 2, I don't want extension. Okay, any question? Good, very good, or not good? Everyone understand?
Very good, mister.
Okay, bye-bye.
So strong,
Take care. Have a nice day.
Yeah, Professor, the graph that you sent out, and we could practice with that for the function equations, right? Oh, okay.
Of course.
Okay. And thank you.
Okay, don't worry. This is just the beginning. We practice a lot of this part.
Teacher.